Welcome to this Smith & Nephew digital education module on the skin, which forms part of a series of modules you can access to develop your knowledge and understanding around wound care. Today we will be discussing the skin. By the end of the module, you will be able to identify the different layers of the skin and understand how these layers interact with each other. You will be able to recall its functions and the effects aging has on the skin. The skin is a complex arrangement of structures with a range of different functions. It is the largest organ in the body, weighing approximately 1/6 of total body weight. It varies in thickness and is intricate in nature. The skin is composed of two main layers, the epidermis and the dermis. Beneath the dermis is the third layer, called the hypodermis or subcutaneous layer. The normal pH of the skin is between 4 and 5.5. Being acidic in nature assists with protecting the body from certain bacteria and fungi. Changes in the skin may be one of the first indicators of an underlying health problem, making knowledge of what is considered to be healthy skin extremely important. For example, if cyanosis is observed, where skin can appear blue, this can indicate poor oxygenation of the tissues. The epidermis and the dermis are made up of sublayers. You can see in the epidermis that there are 5 cell layers. The stratum basal is the nearest layer to the dermis. It's the only layer that consists of cells capable of division. The stratum spinosum is 5 to 12 cells thick. The stratum granulosum is where cells that travel through the epidermal layers towards the surface of skin become longer and flatten horizontally to form the stratum granulosum. This layer is composed of 3 to 5 layers of flattened keratinocytes. The stratum lucidum is a layer that is found in areas such as palms of the hands and soles of the feet where the skin is thicker. This layer provides some degree of waterproofing to the skin. The stratum corneum is the outermost layer and consists of 25 to 30 layers of flattened dead keratinocytes. The cells contain keratin, a protein which helps protect the skin and underlying tissues from microorganisms, chemicals and heat. The cells undergo mitosis in the stratum basal and migrate upwards through each level until they are shed at the stratum corneum. This process takes place over a 28-day cycle. Finally, we come to the dermis, which lies beneath the epidermis. It's firmly attached to the epidermis via the dermo-epidermal junction. It's responsible for providing nutrients and physical support to the epidermis. It contains lymph vessels, nerve endings, hair follicles, and glands. As you can see, the dermis is composed of 2 layers. The reticular and papillary layers. The papillary layer contains the nerves and capillaries that feed the epidermis. The reticular layer is made up of collagen and elastic fibres. Collagen and elastin in the dermis are arranged in a woven network of fibres, giving tensile strength and providing the ability to stretch and contract. Below the dermis is the subcutaneous layer. This layer is made up of connective tissue, fatty tissue, and larger blood vessels. This provides support to the dermis, and the fat stored here provides protection and insulation to internal structures. The skin has a number of different appendages. Firstly, blood vessels. There are 2 main networks of cutaneous arteries. The deep plexus, which is a network of blood vessels, is situated where the dermis and the subcutaneous fat layer join. This network supplies the dermis and subcutaneous layers of tissue with blood. Another appendage in the skin is hair. The shaft of a hair is the segment that projects above the surface of the skin. Every hair is made up of columns of dead, keratinocyzed epidermal cells connected together with extracellular proteins. Nails present in the skin are there to protect the ends of the digits and to allow the performance of intricate movements. The finger and toenails are made of sheets of keratin and are very tough. The skin contains 3 to 4 million sweat glands. These glands release sweat into hair follicles or onto the skin surface through our pores. There are two types of sweat glands, eccrine glands and apocrine glands, based on their structure, location and type of secretion. Eccrine glands are the most abundant on the soles of the feet and produce sweat. They are predominantly composed of water, but also include sodium and chlorine ions, ammonia, amino acids, glucose, lactic acid, urea and uric acid. Sweat glands have an important role in the thermoregulation through evaporation. Apocrine glands are not active during childhood and are activated during puberty. These are our scent-releasing glands, mainly found in the axilla, groin, areola of the breast and bearded regions of the face in adult males. Sebaceous glands are connected to hair follicles and are found on the face, neck and back. They secrete sebum, an oily substance that covers the surface of the hairs and protects them from becoming brittle and dying. Ceremonious glands are modified sweat glands and are found in the external ear. Its function is to provide a sticky barrier and, together with the hairs in the external auditory, can prevent foreign bodies and insects getting into the ear. The skin has a number of different functions: vitamin D production, sensation, thermoregulation, communication and protection. Vitamin D is a fat-soluble vitamin that's naturally present in very few foods. Its production is stimulated by sunlight exposure. Melanin production determines a person's pigmentation and protects against the harmful rays of the sun. Sensation is as a result of nerve receptors in the skin that are sensitive to pain, pressure, touch and vibration, and hot and cold. This makes us able to react to external stimuli such as temperature change. The skin also plays a role in thermoregulation. Receptors in the skin monitor temperature and transmit impulses back to the hypothalamus. This part of the brain coordinates the autonomic nervous system, which includes the control of body temperature. Thermoregulatory mechanisms occurring in the skin include insulation, sweating, and control of blood flow. Sweating cools the body through the process of evaporation via increasing blood flow to the skin. Heat is removed from the body by the process of radiation. When the body is becoming too cold, heat loss is reduced by the process of vasoconstriction, which reduces the flow of warm blood to the extremities from the body's core. Communication is also a function of the skin, as some effects of disease or damage can be seen by observing it. Examples of this would be changes in colour, texture and temperature. Lastly, the skin provides protection, as it acts as a physical barrier for internal organs by preventing loss of fluids so that internal organs do not dry out. The epidermis provides protection from the environment owing to the keratinocytes in the stratum corneum being arranged in a scaffold-like lattice. Additionally, the skin provides protection through immune functions, therefore preventing colonization by harmful microorganisms. Antimicrobial peptides are produced by the cells of the epidermis that kill gram-positive and gram-negative organisms, fungi and some viruses. The dryness of the outer layer of the epidermis and the continual shedding of keratinocytes assists in preventing any sustained growth of organisms on the skin. As previously mentioned, the normal pH of the skin is between 4 and 5.5, giving it an acidic mantle that helps protect the body from certain bacteria and fungi. Further protective elements of the skin include the protection from UV radiation by producing melanin that protects against the harmful rays of the sun. The effects of age to the skin present structural changes that result in an overall thinning of the epidermis. These changes are more marked in women than men, and particularly for those over 70 years old. There is a flattening out of the dermo-epidermal junction, which makes skin more fragile and more susceptible to shearing forces and damage such as skin tears. Changes also occur in the skin's collagen, and elastic fibres lose some of their elasticity. Skin becomes less stretchable and less resilient, resulting in skin folds and wrinkles. Thinning of the dermis causes a reduction in blood supply to the area and a reduction in the number of nerve endings and collagen. This leads to a decrease in temperature and moisture control. To check your knowledge and understanding, try and answer the quiz questions.
Du har nu gennemført Dette Smith og Nephews Wound Club online modul. Vi håber, du kan bruge det, vi har vist i dag i din daglige sårbehandling. Klik på linket i beskrivelsen for at modtage dit certifikat. Tak fordi du så med i dag. Husk at se vores andre moduler om sårbehandling.